Hello, welcome back to my channel, and in this video we're gonna learn about the uncertainty principle, which is a favorite topic for everyone. Quantum mechanics, you must have heard of this uncertainty principle, and we're gonna understand this. Okay, so now let's see what exactly this uncertainty principle is. So if you look at this diagram where you have this wave and you have this amplitude and x-axis is maybe a distance. And so one of the thing, if I ask you a question, where is this wave located? It's very hard to answer that question because the wave is spread out. The wave isn't really anywhere, it's spread out. How do you define such a thing, position for wave? But if I tell you define a property, something called wavelength, which is distance between two crests or two troughs. Okay, so but a wave has well-defined wavelength, but it doesn't have well-defined position. So because it's spread out and position is not well defined. But if you ask me to define wavelength, I can easily define that. I just need to calculate the distance between two crest or troughs. But if you have wave something like this, right? If you have some wave something like this where you have this amplitude and wave is jiggly and it has a sharp peak and then it has some jiggles around and similar x-axis is some distance. So now if you tell me where is this position, I would say the position is really sharply peaked. So in this wave I can define its position. But if you tell me what is this wavelength, I would not be able to define its wavelength because wavelength is the distance between two crest or trough. It doesn't have those. So wavelength is not a well-defined quantity for such a wave, right? So we see this where this if you know the position you cannot define the wavelength. If you know the wavelength you cannot really define this position. So this applies to any kind of wave phenomena, and also it applies to this wave function in quantum mechanics. But in quantum mechanics this wavelength is associated with the momentum. Okay, not and this is by this de Broglie wavelength, the spread in wavelength corresponds to the spread in momentum. So and we have this relation where the uncertainty in calculating the position multiplied with the uncertainty in calculating the momentum is greater than this Planck constant divided by 2. So a small spread in position has a large spread in momentum, and a large spread in position has a small spread in momentum. So it has this inverse relation. The more accurate you calculate the momentum, the less accurate you will have the position. So I hope you like this video. If you do, give it a thumbs up, and I will see you next time.